Hello, and welcome to this video on failure prediction in sheet metal forming, where we will cover what sheet metal forming is, how we predict failure, and why this is important. My name is Alexander Barlo, and I'm a PhD student at Blekinge Institute of Technology at the Dept of Mechanical Engineering. My core area of research is on failure prediction of complex load cases in the sheet metal forming process. So, what is it that I exactly do? In order to answer that question, we need to take a step back and look at what is sheet metal forming. Sheet metal forming is the process of converting thin pieces of sheet metal, no more than 2.5 millimeters thick, into everyday household objects. These household objects can be everything from a simple structure like a kitchen sink to more complex geometries like found in the aviation industry and especially in the automotive industry. So the way sheet metal is formed today can be broken down into 4 steps. The first step is that the material or the sheet metal is received on a big coil. These coils can be several meters long and weigh up to several tons. So therefore, before we start processing it, we need to cut these coils into smaller shapes in order for them to fit into the presses. This is done through the blanking process, where the sheet is cut into a smaller shape, where the shape has often been designed during the component design process in order to minimize the scrap from the production line. Once these blanks are cut, these are fed into a stamping press, where you have an upper and a lower die that ensures that you get the shape or geometry that you are intending to. And that leaves us finally with the component. So what we actually do when we start talking about failure prediction is that we want to ensure the manufacturing feasibility of the component that has been designed. And this we do with the aid of computer-aided tools. In this case, for sheet metal forming failure predictions, we utilize a finite element program. But in order to build up an accurate model, we need some inputs. The inputs that we see to the model is, first of all, the material that we're going to use. We are doing extensive experimental testing on the material to obtain different mechanical properties of the material. We have knowledge about the tools that we have in the press and the press line parameters, meaning how fast it's going, how big of a force it is exerting on the sheet upon closing. And we want information about the friction between the blank or the material and the tools. All of this we feed into a finite element software. In this case, I use AUTOMOTIVE. And what we get out of that is knowledge about necking and fracture on the material. We get knowledge about surface defects, if there are any, and we get knowledge about springback, which is when we lift the die and we see a reversal of the material due to the elastic properties of the material. Where I do my core research is in the top part here when we talk about necking and fracture detection. So how does that actually look like? What you see here is a simulation of an automotive component. The component is formed over several steps, and as you can see on the simulation running, we have some different colors on the part. The different colors correspond to the diagram you see on the left, which is called the forming limit diagram, and is the industry standard for failure prediction today. The main idea of the failure prediction or failure limits diagram is that no points in this diagram is allowed to be above the black curve you see here. So for this part, as you see here, everything is green, blue, or purple, which means that theoretically, from an forming limit diagram point of view, this component is safe. But when we run it in reality, this is no longer the case, and we see a full-on crack in the component. So this is where my research begins to investigate why is it not possible to capture this failure with the tools that we have today, and how can we do that in the future. So why is it important that we increase the accuracy of the way we predict failure in these kind of components? Well, the first kind of business is that we want to make sure that we are able to manufacture the things we have designed before making large investments in the tools needed to manufacture it. From the perspective of the automotive industry, the cost for the tools for a complete car runs up to about 550 million Swedish kronor. So therefore, it's very important that we are sure that we can actually manufacture the design component before we make these large investments. The same way, the finite element simulations and failure prediction of the sheet metal forming process is a very, very strong tool when moving towards safer, lighter, and more environmentally friendly cars. Here it's used for the validation of new high strength, for example, new high strength steel grades, where we can introduce a reduction of material, which will result in a reduction of the total weight of the car, and thereby also result in a reduction of CO2 emissions by the car throughout its lifetime. Furthermore, we can also use it to validate new green steels, for example, the new SSAB fossil-free steel, which has a zero emission manufacturing process. And as you can see, multiple companies has pledged to use this new fossil-free steel in the future. But before we can do that, we need to know how it reacts in a production setup. If we look a little bit into the future, we want to implement the sheet metal forming simulations directly in the flow for the production line. And this we can do with the implementation of digital image correlation in the production line, meaning we have some cameras at the end of the production that tells us how accurate the forming has been of the component. From this knowledge, we can get information about whether we are on target or not, and if not, we can feed some information back to a simulation to tell us, is this something we need to take action on right now, or can we slightly alter some press settings to get it back in the process window, or do we need to actually plan for a maintenance soon? For more information on this topic, you can either contact me on alexander.barlo@bth.se or visit our website productdevelopment.se. Thank you for listening.